Thank you very much for being here today. My name is Stefano, and I work for HomeAway in London, UK. HomeAway, if you haven't heard of it, is a branch of Expedia that focuses on the vacation rental market. And today I'd like to talk to you briefly about Reactive Streams. So here is what I'm going to do. In the first part, I'm going to introduce you to a problem that we tried to solve at HomeAway. And then I'll briefly show you what Reactive Streams are and why they're a great fit to solve our problem. So here's our trouble. HomeAway is on a quest to assert their presence on the vacation rentals market, right? So what we're specifically interested in is digital marketing automation. And we're doing this by dynamic advertisement. And this is an example of what we show as a dynamic ad. Essentially, we want our advertisements to be as effective as possible, right? So we want them to display relevant content to the relevant people at the relevant time. So let's assume someone was on HomeAway.com taking a look at a reasonably priced villa like this, and it didn't book in the end, right? So it's a very good target for us to show an ad like this and try to bring him or her back to the site to convert, right? So the key point here is that whoever displays this thing needs to be up to date with our data, right? And this data might seem static, but it changes a lot, especially the price of our property. They fluctuate a lot. And for this advertisement strategy to be effective, essentially we want to get our data to the advertisement platform, and we need to get it there as fast as we can. So this operation of sending data there is traditionally performed manually, like sending big chunky Excel file somewhere, hoping no one on the other side is on holiday. So that's not really scaling, right? So we want to make this programmatic and like feed the advertisement platforms from our data centers. So essentially, this poses a series of issues, right? So first of all, there's just not one platform. These are some of them, but there's not a whole lot. These guys want different data, presented differently, and they support different integrations. Second, the information that we want to send there is scattered amongst many places in our company, and we've got a variety of sources then we need to integrate. That could be Kafka feeds, REST APIs, you name it. So the problem is growing already, as you see. So essentially, we want to create a bunch of streaming apps that are, first of all, resilient. We want to be always on pumping data to these platforms. We want to react to failure. And we want them to handle change and potentially increase in load. So we want these guys to be scalable as well. So in other words, we want our feeds to be reactive, right? So indeed, Reactive Streams is what we went for. So this fits. So what are Reactive Streams, very briefly, in a nutshell? So diverse streaming applications like the one I just described can become complex beasts, right? Can evolve. But in the end, they can always be boiled down to publishers and subscribers, right? So this is as old as the world. So every single time you try to connect publisher and subscribers, you'll need to take care of a couple of decisions. So you'll need to nail the delivery protocol, as in push or pull, for instance, and you need to negotiate some communication rate, right? Because in the real world, these two guys will definitely work at different speeds, right? So let's assume we want to be efficient, right? So ideally, we like to use push here because, for streaming, push is the most ideal way to go forward. So let's start with that. Let's assume publisher pushes stuff to the subscriber as soon as it comes available, right? So these are just events going from left to right. So now let's make assumptions about these rates, as we were mentioning. So if the subscriber is considerably slower than the publisher, we now have a problem because we don't know what to do with these events that the publisher receives, right? So traditionally, we sort this out by, buffering stuff on the subscriber side. And this is great. Problem sorted, right? Well, clearly not really, because, if the subscriber is consistently slower than the publisher, we just end up with a full buffer. So sorted the problem, have another one. So how do we solve this issue? So first solution is we chicken out. No more push, we just use pull, right? Definitely safer, but not really the efficient way to go forward for streaming, right? So we keep, pulling back for messages, and it's not efficient in terms of resources. Or we could adopt some, dropping policy. We can just start and say, we throw away whatever exceeds the buffer, or maybe we throw away what's in the buffer to make space for the new events. We can adopt some sort of strategy like that. We could even say, ask for retransmission, like in a TCP sort of way. Like this might work in some cases, but not always. Of course, we can imagine scenarios when we don't want to lose events, right? Third solution is, let's make it as predictable as possible. We keep growing our buffer, right? And this actually works until, of course, the fairy tale ends and you run out of memory, which makes everyone sad, and we want to change jobs and stuff like that. So enter reactive streams, right? So reactive streams essentially is a way of switch between pull and push modes here. So you need to think about this as a bidirectional channel now. So the subscriber can request for work units or events, and the publisher can send the work units that are requested. So if you consider a situation like this, where you got, for example, a buffer on the subscriber side which has 2 more spaces for 2 more events, we can actually go ahead and say, please send me 2 of these, because it's perfectly safe for me to receive them, right? So then what happens is that, of course, the publisher sends these 2 events, and if we suppose, we make it a case for the subscriber has not caught up and freed more space, we now end up with a full buffer, right? And at this point, the subscriber can actually not request anything. Like by passive action, we have resiliency built in this case. This is what's called back pressure, so it's really a buzzword lately. It is essentially resiliency built in our protocol. And this makes out-of-memory errors a thing of the past if you employ reactive streams. So that's really good. And performance as well is essentially the best we can get, because the best we can get without jeopardizing resiliency. Essentially, we go as fast as we can, but not faster, right? So Reactive Streams Initiative came up with an encoding of this sort of protocol, at least for the JVM. So these are 4 seemingly simple interfaces that they put together. So we got the publisher, the subscriber, the guys we already know. We got a processor, which is a combination of the 2. And we got a subscription, which is an object that the subscriber can use to request messages, events, sorry. So why did we go down this road for our problem? So first of all, as we showed, reactive streams give you flow control with asynchronous back pressure, and that's giving you built-in resiliency and elasticity, so that's hugely, massively great deal for the resiliency of your systems. Second, thanks to the standardization of these interfaces, essentially it gives you interoperability between a variety of tools and libraries, thus preventing lock-in in a way. So unfortunately, these interfaces that I just show are not really easy to implement. So especially application developers are not encouraged to go there and start implementing them. It does not make a lot of sense. There's a lot of corner cases you need to take care of. So it's much better to rely on existing implementations. And in the Scala planet, because we're Scala people, there's a few of them. I believe there was a talk this morning as well about Monix and Akka streams and comparing them. So the 2 at the top are kind of the most used at the moment, but there are more around. So I'd like just to spend a few more words about why we chose Akka streams as our implementation of choice. So first of all, Akka streams gives you a higher level DSL, of course, on top of reactive streams, and that models every aspect of stream processing. It gives you encapsulate components. They're completely decoupled from reactive streams interfaces, but you can go back and forth very easily. So that's very useful. It is based on actor, so essentially Akka actor is underneath, but you never see actors. So this comes with a little boilerplate because you need to pass around your system, actor system and stuff like that, but it gives you the guarantee of a solid, robust and efficient foundation for your application. Third is Scala native, as I mentioned, so we like that, right? But also it's worth mentioning that it does not rely on many of the language advanced feature. So the learning curve we found is relatively smooth compared to other Scala libraries that are out there. Finally, the community around it is been really great in the past years. It's very prolific, and it came up with all sorts of libraries and tools and integrators to many third parties like databases, message brokers, and stuff like that. So definitely take a look out there what the community is doing. So these were our motivation for going Reactive Streams and Akka Streams. I thank you very much for your time today. I'll be happy to meet you later at the conference, answer all the questions you want, or at the handles you see there. Thank you.
3 minutes more for questions if you want.
Okay, sure. Yeah.
This ready to subscribe interface, this is nice, but it works only inside a single JVM, is it right? How does it work across the JVM boundaries? Can you have something like that?
Yeah, well, of course, the interfaces I've shown are the JVM-ification of Reactive Streams, as you might call it. That's the most advanced. That's where the initiative has made more progress. But there's been a few developments lately also in network protocols that are following the Reactive Stream standards. So, as an initiative is not bound to the JVM, what I've showed, of course, it is, and that's where the systems have evolved more, they've evolved more compared to, on the wire sort of things. So yeah, definitely Akka Streams is still very much local. You could employ actors to bring it out of your JVM if you want. But there's definitely a lot going on in the world of bringing these concepts over the wire. Especially Netflix have been doing a lot of research lately. There's been a talk a couple of weeks ago at the Reactive Summit about the research that they put in exposing these protocols to the wire, and that's very, very interesting. I can give you the details later if you want. Yep.
So at the end, the subscriber will be the platform, so they need to develop something specific to connect with you, or was it a certain way to make them do that?
Sorry, I didn't.
The subscriber.
Yeah.
In your case, it was the platform like Google, there, or was it inside the were making a subscriber which were pushing the data after from Google?
Well, if you think, for example, of a Kafka feed that you want to ingest events from, now you need the subscriber yourself to read from the Kafka feed, right? And then you have to think of this as a pipeline of publishers and subscribers. So then you will have a publisher yourself that maybe publishes to a REST API, for example, that Google exposes, or drops an FTP file somewhere, or this sort of stuff.
Thank you. Thank you.